Hi, this is Carl Nielsen, and this is my oral presentation for assessment number 2, Earth's climate. So let's get right into it. So this is the model of differential equation that we were given for this assessment, created by our climate scientist, Natalie. So our F is our temperature, T is time, and then our K is some constant value that we can change to get different properties out of this. So the way that I created the bifurcation diagram for this is I just wanted to draw out the equilibrium line, pretty much where all our solutions are going to be in equilibrium. So our rate of change is going to be 0. We can think of that as our null-Klein kind of, sort of. So I just wanted to draw that out. So I just set that equal to 0. So we get this, and then this we can just plug right into a graphing calculator to get a graph out. All we need to do is just set our f to y and our k to x, meaning that we're going to use f as our vertical axis or axis, and then our k as our horizontal axis. So that's exactly what I did. I just went into Desmos and I plotted it in here. It gives us this S curve. It's kind of high up there, so I just zoomed in. So yeah, this is our equilibriums you can think of. This doesn't tell us much though on its own. What we need to finish this is we need to see where our value for f is increasing and where it's decreasing. So the way that I did that is I just made it into an inequality. So setting instead of setting it equal to 0, I'd do greater than 0 or less than 0 to isolate positive values for our rate of change or negative values for our rate of change. Pretty much where our temperature would be increasing or our temperature would be decreasing. So first I set it less than 0. I'm pretty sure that's what this is. I forgot. Anyways, this is going to give us our where our temperature is decreasing, so our negative values of rate of change. We can think of if we think of like a phase diagram or phase line. We have these spots. We can think of this as sort of decreasing right here and decreasing right here. So there's that part. The other half is to find where it's increasing. So I just flip the inequality to get this one. Similarly, this is like all the shaded red areas where it's going to be increasing. So increasing and increasing right there. So simple like that. That's how I did that. And then I just put it all together. So we have this. So our blue is going to be where our temperature is increasing. So in all these areas, our temperature is going to be increasing everywhere. And our red is going to be where our temperature is decreasing. So decreasing down to these points. Again, we can think of this as a phase line. If I draw these in right here. So we have increasing temperature right here, decreasing temperature, increasing temperature, and finally up here, we're going to have decreasing temperature. So this is kind of showing us our stability points. So right here we have on this line an unstable point. So everything below is going to be going down and everything above is going to be going up. And then on these 2 points, those 2 points, these are going to be our stable points. where our temperature is going to approach instead of go away from. There are attractors instead of repellers. Um, so pretty much everywhere where there's red below blue is unstable, and where there's blue below red is stable. Okay, so that's all we needed to do for task 1. So for task 2 and 3, I'm going to be going to Desmos so we can get a better visualization of this. These are just the equations that I got to make this work. So right here, our initial value is, or we have for our initial K value is 0. And our initial temperature is going to be 68. So this purple line, it might be hard to see, is going to be our K value, and then this black dot right there is going to be our temperature. So, and the first thing that happened is President Jeffrey deregulated our emissions so that our K was now -7. So there we go. If we zoom in here a little bit, so we can see our K is -7, and we know that this blue means that the temperature is going to be increasing. So we can imagine our temperature is going to increase. It'll reach this point right there. Right there, it's going to become 69.4 degrees. I guess Fahrenheit. Yep, Fahrenheit. At the equator. So that's the first step. It's just going to come up there. The second thing that happened is Clive lobbied for an additional 0.35 to that deregulation. Now what we notice here is that it's increasing here, and it's going to, our temperature is just going to zoom past right there. It's going to keep going up. All the way up to here. So eventually our temperature is going to reach that right there, 79.4 degrees Celsius. So about 10 degrees warmer than it was just a little bit before. So then our new president, Cicely, she's going to reduce our K back down to -7, or I guess increase it to -7. But we're still up here, so we're still only going to go to 79.4 degrees. And then after that, she makes efforts to move all the way back to a K of 0, which we can see is going to bring our temperature to 79 degrees at the equator. So we started at 68 and now we're at 60 or 79. That's pretty much how I got to that temperature, is just kind of following along that path. With the events that happened, that's how I reached that equilibrium temperature of 79 degrees. So now we need to propose a plan to Cicely in order to get our temperature back down to 65. So knowing that this is a stable point, there's not much we can do in the way of like moving it along this line to decrease our temperature. What we'd have to do is we'd have to come all the way over to this point over here, and then get our K value high enough that we can fall off and drop down. So if we do that for a little bit, we can imagine that our value for K is going to be increasing all the way up until this point. So our K value is going to be 19.28. And at this point, I guess just barely past that, we're going to kind of get over this hump that was preventing us from decreasing our temperature even further. So then our temperature is able to fall all the way back down to down here below like about 66 degrees, below what it started at. And then if we want to, we can then increase our K or decrease our K back down to 0, because again, we're on another stable point over here. This line is going to be a stable line where our it's an attractor where our temperature is going to be attracted to. So then we can decrease our K back down to 0. And eventually, if our K is 0, we can get our Z back, or our final temperature back to 68 degrees. So that's how we solve that climate crisis, I guess you could call it. Um, and yeah, that's how I thought through this problem, how I solved it, and kind of visualized it in my head. Um, and yeah, thank you.